Hey team, how we doing? In this video we're going to start looking at some algebraic fractions, our next topic. In this one we'll go and do some evaluating, so basically substitution, which is not difficult at all, and simplify a bunch of other algebraic fractions. Okay, so let's start with example 1. So let's try to do this without a calculator. Otherwise, it's super simple. So this just becomes 2 minus negative 3 over negative 5, which becomes 5 on negative 5. Whoops. Which equals negative 1. Excuse my not so good looking 5s. Okay, and B, very similarly. So 2 minus negative 5 minus negative 3 over B take A. Alright, so if we work this out, this gives us 2 plus 5 plus 3, which is 10, on negative 5, which is negative 2. Done. Okay, so easy peasy there. Let's move on. Okay, simplify. Right. So remember, we can always cancel out factors. So that means an A in the numerator and the denominator can go, so that's what we're left with, A on 2. So for this one, well, 6 divided by 3, 6 and 3 becomes 2 and 1. Factor of 3 can go, and then A squared has to stay, and then B can go as well, so 2A squared. Now this one, the only way we can simplify it really is, so we cannot cancel the A's, alright, so please don't do that. A right now in the numerator, the A here is not a factor, it's a term. We can't cancel terms. But what we can do is rewrite this like this, since it has a single term denominator. So it'll be A over A plus B over A. So this essentially becomes 1 plus B on A. So if there was anything to do with that, we can do with that this expression. That's about it. Not even sure that's fully like whether or not that is actually simplifying, but I guess that's what we want. Okay, example 3. All right, so what we should do here is, order of operations, right? Do your powers before you do anything. Powers and brackets before you do anything else. So let's just get rid of the brackets and square it. So we get 16b squared over 2b. And then, all right, 16 and 2 becomes 8 and 1. So it'll be 8b. And then the b on the denominator will go. So that's it, 8b. This one, okay. So the denominator is already in a factorized form. So basically, we can go 18 and 3, that becomes 6 and 1. So we're left with 6 over C take 1. All right, and that's it. The denominator's got 2 terms in it, so we are not going to split that up. All right, example 4. Simplify. Okay, well, it's already factorized for you. So look for any factors you can cancel or simplify. So we are literally left with x plus 4 on 5. And let's leave it like that. I wouldn't bother splitting that up. Okay, this one, so 12 and 3 become 4 and 1. And one lot of the brackets will go. So we're left with 4 outside of x plus 4, and we don't need to expand that. You can if you want to, but I'm just going to leave it like that. Okay, example 5. Okay, numerator. So we cannot cancel any, we cannot do this, because please don't do that ever, that's wrong. You need factors before you cancel, so you're going to factorize the numerator. And now you can get rid of the these 3's, okay? So the simplified version is a plus 3. Same here, let's do the same thing. So 4 is a common factor, we get a plus 3 over 8. All right, now 4 and 8 become 1 and 2, so we're left with a plus 3 over 2, and I will just leave that. Let's do 6 now. Okay, so now we don't have numbers, we just have a bunch of variables, or more variables, because B we have some numbers. Okay, so common factor in the numerator, factorize A, so we get A outside of B plus C over B plus C. All right, so now that B plus C is a factor, that can go, and we're left with A. Now let's do B. Okay, factorize both numerator and denominator by looking for common factors. Highest common factor in the numerator is 6x, so we get x minus y. Highest common factor in the denominator is 3, and we get x minus y. There we go. So the x minus y, are factors, they can go, and 3 and 6 can become 2 and 1, so we're left with actually 2x. All right, question 7. This is a useful rule that I've got here for you. All right, you'll apply this when you are close to a identical factor in the numerator and denominator. All right, and if you just use this rule, you'll get there. So better just to show. Okay, so numerator, let's factorize out the 6. We get a minus b, right? Over b minus a. Now, this is what I was told. This is what I mean. So a minus b, b minus a, very close, right? But not the same. So you can't cancel them just yet. They're not identical factors. But what you can do is you can apply this rule to either one. Either one. You can, if I put the denominator in brackets, you can apply this rule to either one, but you only want to do it to one of them. I might just do it to the numerator. So this will become negative 6 because of this negative 1. And then it becomes b minus a. All right, so if we do that, that actually hasn't changed the value of that expression at all. All right, I hope that makes sense. And we can keep going. All right, so because that's basically like saying, okay, if this was positive at the start, then this becomes negative, right? Because you've swapped the numbers around. And then to kind of counteract that, you got to times it by negative 1. All right, so that's why this works, and it doesn't actually change the value of whatever expression that is. All right, so now we have a common factor to get rid of, and we're left with negative 6. And let's see if we can have to do the same thing to b. All right, so highest common factor, numerator xy, we get y take 1 over 1 take y. All right, so see how y take 1, 1 take y, okay, we want to make them the same. So I usually just do it to the numerator, because usually it's the denominator that goes. So it will get negative xy 1 minus y over 1 minus y. And the 1 minus y's go, so we're left with negative xy as our simplified expression. Okay. Lucky last, simplify this. Okay. So simplify, a lot of the time you have to factorize, so just keep looking out for things like difference of two squares, perfect squares, quadratics to factorize. That's going to serve you very well going forward. So numerator is a difference of two squares, so let's do that. I won't rewrite all the rules here, so if you need to go over the rules, make sure you do so. Whoops. I don't know where that came from. Let's go back. to 10 AB examples. Hello. Alright, so where were we? Okay, so that the numerator here was difference of 2 squares, so x squared take 1 becomes x plus 1 bracket, x minus 1 brackets. And then denominator is a quadratic, so two numbers that multiply to positive 2, add to positive 3, we get x plus 2, x plus 1. And then we see we have a factor that can go, so we're left with x minus 1, x plus 2 is our solution. And then let's do b. Okay. Always look for common factors first before actually going, before you try to apply like factorizing quadratics or whatnot. So numerator has a common factor of 2. We have 3x squared plus 5x minus 2. And then in the denominator, we have a common factor of 3, so we have 6x squared plus x minus 1. Okay. These are just a little bit harder to factorize. Harder, a little bit just longer because they're non-monics now. So see, we got 3 and 6. It's not as straightforward as this one. So what we want is to, if I just do it the full long way, we want two numbers that multiply to AC, so negative 6 for the numerator, and add to positive 5. So that means we have 6 and negative 1. And again, I've said this before, if you have your quicker way to factorize a non-monic quadratic like this, just use it. But this way always works. So split the middle. I'll do it to the bottom as well. We want two numbers that multiply to AC, so negative 6, and add to positive 1. So that is 3 and negative 2. Yep. And then from here, we factorize. I'll use square brackets now because I'm going to have to write more brackets just to keep that distinction between what I'm actually factorizing, because the 2 out here still needs to be multiplied by everything, right? So 3x outside x plus 2 minus x outside of, minus 1 outside of x plus 2. Yep, so remember, factorize 2 at a time, so factorize that, common factors, and then factorize this using a common factor of negative 1. Right, because we want our brackets here to be the same, so we have a common factor. Alright, so denominator becomes 3x outside of x plus 1 minus 1 again outside of 2x plus 1. I missed that because this should be 2x plus 1 as well. Alright, so I should put the 1 there because I put the 1 in the numerator. So this one's just longer, as you see. And then we have 2 outside of x plus 2, 3x minus 1, outside of 3, 2x plus 1, 3x minus 1, because look what you see here. Okay, common factors go. Our simplified solution to this expression is 2 outside of x plus 2 over 3 outside of 2x plus 1, and there's no more for us to do there. So that is by far the longest one there. I was actually looking at this at the start and thinking about whether it was this long or not, but it turns out it actually is. All right, so that's it for this video. So lots of algebra again. Now we're applying algebra to algebraic fractions. All right, see you in the next video.